Today, we are tackling a question that, honestly, haunts the entire field of AI. What is actually going on inside an AI's mind? We're going to break down a brand new master plan that could finally, and I mean finally, crack open that black box for good.
I mean, really think about it for a second. We're already trusting AI to help diagnose diseases, to manage our money, to keep us safe. But if you were to ask one of these systems why it made a certain call, you'd pretty much get a digital shrug. And this isn't just some techie problem. No, it's a huge issue of trust.
This is what everyone in the field calls the black box problem. We can see the inputs, right? The data we feed into it. And we can see the outputs, the decisions it spits out. But that whole middle part, that complex, messy process with billions of connections happening, it's a total mystery. And if we can't see inside, how can we ever be sure an AI is being fair or reliable or even safe?
Okay, so here's our game plan for today. We're going to start by looking at the old ways people tried to solve this and, why they kind of fell short. Then we'll get to the exciting part. 2 powerful new ideas that are changing everything. We'll see how they come together in a 5-phase master plan. And then we'll connect all of that to the ultimate goal, building a future with AI we can actually trust.
So let's go back a bit. How did we first try to peek inside this box? Well, the initial attempts all fall under this umbrella called Explainable AI, or XAI for short.
The first wave of these tools were all post hoc, which is just a fancy way of saying they tried to figure out a decision after the AI already made it. They might show you which pixels in a photo the AI was looking at. But honestly, it's like trying to guess the chef's secret recipe just by looking at the finished meal. You might get a few clues, but you're missing the whole story of how it was made.
And that leads to some really big problems. For one, these methods are super fragmented. They look at one tiny piece of the AI here, one layer there. They're bolted on at the end, not designed in from the start. They totally struggle with the massive AI models we have today. And here's the real kicker. There's often no way to even prove if the explanation is correct. They show us what things are related, but not what actually caused the decision.
So yeah, those old methods just weren't cutting it. We needed a totally fresh approach. And that is where 2 powerful new ideas come into the picture, and they are completely changing the game.
First up, we've got something called Mechanistic Interpretability, or MI. So forget about just looking at the final answer. MI is all about popping the hood, getting your hands dirty, and reverse engineering the AI's internal wiring. It's like being an AI mechanic, tracing every circuit to see exactly how the machine works.
The second huge idea is Neurosymbolic AI, or NeSy. Now, this approach is just brilliant. It basically combines the best of both worlds. It takes the raw pattern-finding power of neural networks, you can think of that as the AI's intuition, and it merges it with the clear, structured logic of symbolic AI, which is like its rulebook. So the AI isn't just learning from patterns, it's also thinking using explicit rules that we can actually read and understand.
So how do these two fit together? Well, think of it this way. Mechanistic interpretability is the art of cracking open a sealed box to figure out how it works inside. Neurosymbolic AI, on the other hand, is about designing a box with clear windows from the very beginning. One is about analysis, the other is about design. They're really 2 sides of the very same coin.
And the difference this makes, it's just massive. The real shift here is going from just seeing correlations to actually understanding causation. A traditional method might tell you, hey, the AI seems to connect fluffy ears with the word cat. But MI aims to show you the exact circuit inside the AI that computes fluffiness, combines it with the concept of ears, and then uses that to trigger the cat label. This means we can make targeted, surgical fixes instead of just fumbling around with trial and error.
Okay, so we have these 2 incredible concepts. The billion-dollar question, though, is how do you actually bring them together in a practical way? Well, that's where this new master plan comes in. The whole goal is to create what they're calling interpretability by design.
And the plan lays out this really logical 5-step process. First, you identify your key pieces, the neural network part that learns, and the symbolic part that uses rules. Then, you use MI to actually map them to each other, so you can say, this specific circuit is responsible for this specific rule. Phase 3 is absolutely critical. You have to verify that link to prove it's a real cause and effect relationship. After that, you can evaluate the whole system's transparency using new kinds of measurements, and finally, you optimize it all to make sure it runs well.
Let's just zoom in on one of those new metrics for a second, because it's a great example. It's called the Symbol Fidelity Score, or SFS. It asks a really simple but powerful question. If we ignore the complex neural network and only look at the simple human-readable rulebook, how well can we predict what the AI will actually do? A high score here means our simple explanation is a really faithful guide to the AI's complex behavior.
Now look, I know this all might sound super technical, but the implications here are absolutely enormous. This isn't just about understanding the AI we have today. It's about building a safe and solid foundation for the ultimate prize in AI research, artificial general intelligence, or AGI.
AGI is what some people call the holy grail of AI. We're talking about a system that isn't just a master at one thing, like chess or writing emails. We're talking about an AI that can learn, reason, and perform across almost any task at, or maybe even way beyond, the human level. The potential power of a system like that is just staggering.
Researchers at places like Google DeepMind have even started mapping out what this journey to AGI could look like. You can see it as a climb through different levels of skill, from just competent to expert, all the way up to virtuoso and eventually superhuman. And as we climb that ladder, the stakes just get higher and higher.
And this brings us to the most important point of all. We simply cannot risk building a superhuman AI that is still a black box. It's just not an option. As these systems get more powerful and more autonomous, being able to understand and trust how they think, it's not negotiable. Transparency stops being a nice feature and becomes an absolute prerequisite for safety.
And this quote really sums up the core takeaway here perfectly. Fusing these two ideas, neurosymbolic AI and mechanistic interpretability, gives us a real concrete path forward. It's a strategy to design AI that we can understand from the ground up, instead of just trying to guess what it's doing after the fact.
So that leaves us with this one big, fascinating question to chew on. To build a truly intelligent AI, do we first have to build one that we can completely take apart and understand? If we ever hope to create something that's smarter than we are, maybe, just maybe, the very first step is making sure we can always understand how it thinks.